Notes 4.3. Using logarithms to solve exponential equations. When solving an exponential equation, what should one do if the powers cannot be written with the same basis? So if you can't do that, you have to rewrite in log form. And then we're going to use the change of base formula, and then we're going to put that in our calculator. So we need to know what the change of base formula says. So log base b of a number is equal to a log divided by a log of any base, we'll call it c. And then just remember b goes on bottom, so we'll write b, and then the number goes on top. So example 1, let's take a look at these problems. 10 to the what power gives you 1,000? So 10 times 10, how many times would give you 1,000? So x would equal 3. 2. 10 to the what power will give you 55? Now you try to write the same base, but you can't. Then you approximate and you say it's probably between 1 and 2. So we know that this is approximately equal to 1 point something, because it's between 1 and 2. Alright, so now that we know how to put it in log form, we're going to go ahead and put it in log form. So log base 10 of 55. Okay, since our calculator's base is in base 10, we're going to just go ahead and put in our calculator. So what I'm going to do is I'm going to pull up my calculator. Okay, I'm going to find the log button. The log button is right here. I'm going to hit log, and then I'm going to hit the number 55, and then I'm going to hit enter. And so our answer is 1.74. That means if I go 10 to the 1.74, I should get pretty close to 55. So I'm going to check with my calculator. So I'm going to hit 10, and then I'm going to do the exponent key, which is that key right there, to the 1.74, and I hit enter. The reason why it's 54.95 at 4 is because I rounded. The closer I am to this number right here, the closer I am to 55. Alright. Okay, example 3. Go ahead and full screen this back there. 5 to the what power will give you 145? So 5 squared is 25, 5 cubed is 125, 5 to the 4th is 625. So I know my answer will probably be 3 point something, and closer to 3. So I'm going to put this in log form. Log base 5 of 145 is equal to x. Okay, then I'm going to use my change of base formula because the base is not 5, and we know our calculator's base is, because our calculator's base is 10, so that's why I have to change the base. So log base 10, and the base is 5, so 5 goes on bottom and 145. So I'm going to put that in my calculator. Log 145 parentheses divided by log 5. And I should get close to 3 point something. 3.09, let's round, so 3.09. We're going to round to the hundredths. So that's why it's approximate. So that's why the equal signs are squiggly. Okay, on question number 4, there was a typo. There should be 3 to the x, not 3x. So let's go ahead and write that. 7 plus 3 to the x equals 30. Okay, so here's a variable. We want to get that by itself, so we're going to subtract 7 on both sides. 30 minus 7 is 23. Okay, now I'm going to try to get this in the same base, but I can't because 3 squared is 9 and 3 cubed is 27. So I'm going to put this in log form. Log base 3 of 23 equals to x. And then I'm going to write this so I can put in my calculator. So I'm going to get x equals log 23. And this is the base 10 of 3. So I'm going to get that in my calculator. It should be between 2 and 3. So 2 point something closer to 3. I get my calculator here. So I got log of 23 divided by log of 3. Enter 2.85, and that makes sense because 23 is closer to 27. Last example here, example 5. 7 to the 3x plus 2 equal to 5. We're going to try to get the same base. You can't, so we're going to put this in log form. Log 7 of 5 equal to 3x plus 2. We're going to put this part in our calculator. Log 5 over log 7. Okay, so I'm going to get my calculator. I'm going to put that in my calculator. Okay, so log of 5 divided by log of 7 should be around 0 point something. 0.83. Okay, I'm going to do my two-step equation and subtract 2 on both sides. So just take the calculator, hit minus 2, enter, negative 1.17, then divide by 3. So x is approximately equal to negative 0.39. Thank you for listening to Notes 4.3, using logarithms to solve exponential equations.